Hey, friends, let's do some review. Let's go back to chapter 7 and 8 and 9. Let's look at some questions that you might see on the end of the RICE test. So the whole purpose of these RICE practices is to make the actual RICE test not as uncomfortable and awkward and overwhelming. So I'm hoping that by you getting a lot of exposure to what the RICE test will look like for math and the type of questions you'll see, that on the actual RICE test, you'll be like, oh, I've got this. This is no biggie. Okay, so let's get started. I am going to talk myself through as if I were doing this test as a sixth grader, right? So these questions I actually haven't solved yet. So there I may make some mistakes. I may be stuck for a little bit, and you're going to see the way that I kind of talk myself through it. And in the process, you can also remember the things that I am remembering, and that'll make it so much better for you. All right, so let's start with the first question. What is the value of the expression when x equals 2? So if x equals 2, that means that anywhere there is an x, I am going to put a 2. So I'm going to rewrite this, but now I'm going to rewrite it with a 2 everywhere there's an x. I'm going to remember that coefficients and variables are always times together. And now that I have this beautiful expression, I can solve that. I know all of the values. So now I need to remember the order of operations. I'm not just going to go boop and then boop and then boop, am I? Because there's a specific order in what gets done first. This is where you need to remember PEMDAS. So there's no parentheses. I'm going to do my exponents first. I have two exponents here. So when I do those, 3 squared, I'm going to remember, is 3 times 3, just 2 times, right? 3 times 3 is 9. 2 to the third is 2 times 2 times 2. It's 2 multiplied by itself, and then the exponents tell us how many times, which is 3 times. So 2 times 2 is 4, 4 times 2 is 8, and then I'm going to bring everything else straight down. Minus 32 plus 8. Okay, so we've done exponents. There is multiplication, so I'm going to do, oh, good thing I saw that. I'm going to multiply next. 3 times 2 is 6. So now I bring everything else down. Done the multiplication. There's no division. So now I'm on to add and subtract. I do that from left to right. And is it not showing? Hello? Nope, it's not, is it? Let's try that again. Please hold while my iPad connects to my computer. It's a beautiful waterfall though, isn't it? I didn't know we would already need a brain break. All right, so what you can see, I might have to redo what I just did, is I brought everything straight down and then I multiplied. So I did the multiplication. There was no division. So now I'm on to adding and subtracting. We do that in the order that it appears from left to right. And in this expression, the subtraction is first. So 9 minus 6 is 3. 3 plus 8 equals 8, 9, 10, 11, 11. So the correct answer is 11. All right, the next one says quotient. I'm going to remember that quotient means divide, sum means add. Write these down if you've forgotten them. Product means times, difference means subtract. If you couldn't remember those, then you better make sure you write them down and remember them now. So the quotient of 56 and n is multiplied by 3. Part A says create an equivalent expression using n to represent the unknown numbers. We're going to use n right there. So the quotient of 56 and n, I can write that. The quotient of 56 and n is multiplied by 3. Okay, so now I'm going to do that, and then I'm going to multiply it by 3. Awesome. So now part B is what is the value if n equals 8? Well, now I can replace that n with an 8 because it says n equals 8. So 56 divided by 8. I'm going to do that, and then I'm going to times it by 3. Well, that's 7. 7 times 3 is 21. 21 is the value of that expression. The temperature outside is 95 degrees Fahrenheit. Oh, using the formula C equals 5/9. Remember that anytime we have a number next to parentheses, it always means times F minus 32. What is the temperature in Celsius? So I'm trying to get to Celsius. I need to know what F is. 95 degrees Fahrenheit. We do know what F is. F is 95 degrees. So I'm going to rewrite this expression. This time I'm going to rewrite it with the 95 right there. All right, so 95 minus 32 is 63. So 5/9 times 63, I'm going to make that a fraction. And then I'm going to simplify those. Now when I multiply straight across, and I get 35 over 1, which is 35 degrees Celsius. So if you're anywhere else in the world besides the United States and it's 35 degrees, that actually means it's 95 degrees Fahrenheit, what we're used to. Very cool. All right. Create an expression written as the product of two factors. All right, I remember from up here that product is times, so product means I'm going to be timesing, and then factors. Factors are the things we times together. 3 times 9 are factors of 18. So factors are the numbers we're timesing together. Okay, oh, that makes sense. The product of two factors. Okay, the expression should be equivalent to 30 and have at least one exponent. Okay, I need the product of two factors, and one of these needs to have an exponent. Okay, so I know that like 2 squared is 4, but 4 times nothing. Yeah, that wouldn't work because 4 is not a factor of 30. Okay, what if I did like 2 cubed, which was 8? But 8, that wouldn't work either. Okay, let's do like 3 squared, that's 9. That doesn't work for 30. Maybe I'm going about this wrong. Maybe I need to find the factors of 30 first. So I can do 5 and 6. I can do 10 and 3. What are other factors of 30? 2 and 15. Anything else? Not really. Oof. Okay. I don't know if I can make exponent out of any of those unless, what if I just did 2 to the first power and then times that by 15? Technically, that's a product of two factors. Ooh, I've got another idea. Okay, what if we did this? What if we did 2 squared, which we know is 4, right? And then what if we times that by, no. Okay. Times it by, oh shoot, maybe this won't work. Can you guys think of something better than I can? I'm trying to get like a subtraction problem. So 2 squared minus plus 1, 2 squared plus 1 times 6. That would equal 30, and it's still the product of two factors. 2 squared, that'd be 2. 4 plus 1 is 5. Then 5 times 6 equals 30. I think that would work. I like that. I want to see what you guys come up with. That was mine. So I was looking for the product, so I had to times two things together. These are the two things that I times together. It does equal 30, and it does have at least one exponent. Feel good about that. All right, let's go on to the next question. An expression is shown. 5x plus 3y minus 2x minus 2y minus 3. Part A, which are terms in the expression? Choose all that apply. All right, I have got to rack my brain and remind myself, what are terms? Terms are everything between pluses and minuses. Do you remember that? Do you remember how I taught you how to figure out what a term is? Underline, and then once you get to a plus or minus, stop. So 5x stop is a term because there is a plus right here. So now my new term is going to be positive 3y stop. There's a minus right there. So the next term is negative 2x stop because I see a minus right there. And I'm going to go till I see another plus or minus. And there we go. Woo! So if the question was how many terms are there, I would say 1, 2, 3, 4, 5 terms. That's not what it's asking. It's asking which are terms. So whatever I have underlined. Negative 2y is underlined, so I'm going to circle that. 5, it's got to be 5x, so not just 5. Positive 3y is underlined, and that's the same as just 3y. 5x is also underlined, and there are some y's, but that's not the whole term. Let's use another vocabulary. Just the letters are variables. Remember that? And then do you remember what's always, always, always in front of a variable? The coefficient. Remember, the coefficients are like the co-pilots. They're always in front of a variable, and we have kind of our two pilots, and the coefficient is one of the co-pilots. Coefficients and variables like love, love, love each other. They're always together. So, is that a good reminder for terms? All right. That little vocabulary lesson is very useful because the next question is, which expression has a coefficient of 3? Remember what I just told you about coefficients? Coefficients are in love with variables. Every variable has a coefficient leading the way. So I see a bunch of variables here, but the coefficients are in front of the variable, so it's not that one. And coefficients are always times with variables, not added. So the correct answer is 3y is the only one that has a coefficient of 3. Now this y cubed has a coefficient. Like I told you, every variable has a coefficient. It would just be a 1. Or this 3 plus y, that y does have a coefficient. If it's not there, then it's just the number 1. There's another good reminder for you. All right. Oh, guys, we missed a part B. Oh, I bet you were yelling through the video. Mrs. Madsen, there's a part B. Okay, part B says create an expression that is equivalent to the expression. So equivalent means the same. So we have to have it have the same value. Now it doesn't have to look the same, but it has to equal the same. All right, so what I'm going to remind myself then is I can combine like terms. So I am going to come back to here and I'm going to put all my X's as pinks and all my Y's as green. And my constantly alone is blue. They're blue and lonely. So I'm going to combine those X's. 5x minus 2x will give me a positive 3x. And then 3y minus 2y will give me, if I have 3 y's and I get rid of 2 y's, I still have a y left over. So I'm going to do a positive y, and then I have a minus 3 by its lonesome. So these are the exact same expressions. It's just that I combined them. I combined all the fries together in one part of the order and all the drinks together in one part of the order. Only it was x's and y's that I combined all together. Josh and Lila each earned 100 points while playing a game. Lila received 50 additional points for completing the bonus round. Josh received n fewer points than Lila did in the bonus round. Create an expression using n that shows Josh's total number of points. That was really wordy. I'm going to want to see if I can draw it out. So we got Josh and we have Lila. Josh and Lila each earned 100 points while playing a game. Lila received 50 additional points for completing the bonus round. So Lila gets an extra 50 points. Josh received n fewer points than Lila. Fewer means subtract. So Josh didn't receive 50. He received n fewer than. And I put n kind of in the back because fewer than, if you remember, is that turnaround word. And it just makes sense in this example when if Josh received less than Lila, to take Lila's points and then get a few less and then get the ones less out of the way. So that's why I have 50 minus n for Josh. Okay, create an expression using n that shows Josh's total number of points. So this was his total number of points. He had 100 points, and then he had in the bonus round, he had n fewer points than Lila, and Lila was the one that had 50. So that is the expression for Josh. The next one is if Josh received 20 fewer points than Lila in the bonus round, how many points did he earn? All right, so the n is the fewer points, and we found out that it was actually 20 fewer points. That's what n was, so we can actually plug n in right there. So it'd be 100 plus 50. We can plug in 20 right there for the n. So I'm going to do the bonus round first. You got 30 points in the bonus round, 100 points earlier. So he had a total of 130 points. Now that was one that when I first read it, this was one that I worked out because when I first looked at it, I was like, what in the world? It's a lot of reading for a math test, huh? But then as I read through it a couple times, and this was really helpful to me, drawing it out. Once I figured that out and could see just the numbers, it wasn't as overwhelming. So that really helped me. So hopefully you do that strategy as well. Which table represents the expression 12 plus x? All right, so this is our XY chart, isn't it? So if I plug in a 1, I should get 12 plus 1, I should get 13, huh? Oh, but this is 11. So that's definitely not. And this, when you plug in a 1, 12 plus 1 doesn't equal 12. That'd be 12 times 1. So that's not the expression. That's 12x would be the equation there. This one, nope. No, oh yeah, that's divided. I don't know what that is. Not that. This looks good because 12 plus 1 is 13. 2 plus 1 is 14. 12 plus 2 plus 12 is, okay, I'm good. 12 plus 3 is 15. 12 plus 4 is 16. That is the correct answer. So with questions like this, you want to plug in the x and make sure that the correct answer comes up. So it goes through there and then it comes out there. All right. Sarah and her brothers need to mow at least 20 yards this summer to have enough money to go to Lagoon. Create an inequality to represent the total number of dollars and Shara and her brothers need for a lagoon. All right, inequality. We've done expressions, and that's like this. This is an expression, okay? An equation is this, but with an answer, right? Get out of the way, Miss Matson. That's an equation. It just includes the equal sign. An inequality, though, is when we compare two things with either a greater than, a less than, a greater than or equal to, or a less than or equal to. That is what an inequality is. I want to write an inequality that shows that they need to mow at least 20 yards. We're going to use N for how much money they need. So they need at least 20 yards. So what does at least mean? Well, if they do exactly 20 yards, that'd be okay. If they did less than 20 yards, would they be happy with that? No. They, at least means that's the least amount, right? Would they be okay if they did more than 20 yards? Yes. So at least means greater than or equal to. So the inequality is N is greater than or equal to 20. If C times N is greater than 15, what could N equal that would make the inequality a solution? Here's another vocabulary word. Solution means an answer or like a correct answer. Something is a solution, it works, right? So if we plug in 0 for N, would that make it true? Well, 6 times 0 is 0. Is 0 greater than 15? No, so that is not the correct answer. It's not the correct solution. What if we replaced it with 1? 6 times 1 is 6. Is 6 greater than 15? No. All right, let's replace it with 2. 6 times 2 is 12. Is 12 greater than 15? No, that is false. Oh, this last one. What is 6 times 3? 6 times 3 is 18. Is 18 greater than 15? Yes. There we go. We have the correct answer. Okay, so hopefully you heard of some words that you knew, and if you didn't know them, you remembered them, and you're good now with inequalities and quotients and products and terms and all of that, so that you can do really well on these questions coming up on the RICE test. Hopefully you saw me talk through and reread when I needed to figure out what the answers were. So good luck to you. The more you practice, the better it will be. See you later.